Good morning, everyone. Welcome back. Today, we will be closing up chapter or unit 8. Today, our unit is lesson 8.12. This one is going to be a little tricky. As usual, this will only be the Think About It section. Today's date is April 8th, 2020. Okay, please make sure that you have the right heading. Think about a question for today. It says, the diagram shows a regular hexagon, which is broken into congruent triangles by drawing 3 diagonals. Explain why it makes sense that the given angle is 60 degrees. Knowing that one side of the hexagon is 4 units long, determine the length of x and the length of h, which is the altitude of one of the triangles in the diagram. And finally, use your answers to part B to find the area of one of the 6 triangles and the area of the hexagon. So first, let's draw that hexagon. Quick trivia for today. Does anyone know what kind of festival is happening in Jamaica right now? Okay, says this one is 60 degrees. It says we have perpendicular, we have H, and we have X. It says that one side is 4. Okay, perfect. So part A says that we are to explain why the 60 degrees makes sense. Now, in order to do this, we have to recall from a long time ago when we were trying to find out what are the angles of different polygons. Now, if you recall, the angles, or all the angles within a circle, must add up to 360 degrees. Now, if you continue this circle, go all the way around, that would mean that all of these angles within the circle should add up to 360 degrees. So we have 360, and since this is a hexagon, we know there should be 5 triangles inside there, or 6, there's 6 triangles, sorry. 1, 2, 3, 4, 5, 6. 6 equilateral triangles. So if that is the case, then we can divide this 360 by 6, and that's how we would get 60 degrees for just one of these triangles, or for one of those big equilateral triangles. But what about this angle right here? Okay, what about that angle? If you notice, it's half of one of those equilateral triangles. So if the whole thing measures 60, then half of it should be 60 divided by 2, which would give you 30 degrees. Hope that's clear. Also, if this whole side length here is 4, then from here to here is 4, but half of that should be 4 divided by 2, which should give you 2. Okay? So looking on it, x, therefore, should be equal to 2 units. Okay? So for part B, it's asking us to determine the length of x, which we just did, and to find the length of h. or the height or altitude. Okay, so for h, we know the angle. So our angle here is 30. We have opposite and we have adjacent. So the function that we should use is therefore tan. So tan of 30 degrees is equal to opposite, which is 2, over adjacent, which would be our h. Now using the little math tools that I gave you before, we know that we can just put the h up here and put the tan of 30 down there. So we can rewrite this as h equals 2 over tan 30. Okay. And when we do that on our calculator, we should end up with 3.5 units, and that should be our height. Okay. Now to do our part C, it says to find the area of a triangle. So area of a triangle is half times the base times the height. So 1/2, you can put that as 0.5 times the height, which we just found to be 3.5, times the base, which is 4 units, okay, because it's a whole 4 units, right? And that should give us 7 units. Okay. And it also wants us to find the area. Did I just spell area that? Area, sorry, of hexagon would be number of triangles in the hexagon times the area of the triangle. Now, since it's a hexagon, it should be 6 triangles times the area of the triangle that we found. So it should be 6 times 7, which will give you 6 times 7 is 42 units squared. Okay. Don't forget to put your units squared whenever you're doing these, since we're finding the area. Okay. Hopefully that helped, and I'll see you in class.